Hey, welcome! Today, we're going to tackle one of the most incredible manufacturing processes on the entire planet, how we turn simple, everyday sand into the super powerful brain inside your smartphone. It is a journey of almost unbelievable precision. So this is the big question, right? How in the world does that actually happen? How do we take something as basic as sand and transform it into a piece of tech so complex it can run artificial intelligence? Well, that's exactly what we're going to unpack. Okay, so before we even get to the sand, we have to understand what makes all our modern gadgets tick. And the secret, really, is in these things called semiconductors. The best way to think of them is as billions, and I mean billions, of microscopic switches. They control the flow of electricity, and they are the foundation for, well, everything, from your phone to the entire internet. And that really brings us to the main goal of this whole unbelievably complicated process. If you boil it all down, it's about this: creating and wiring up billions of these tiny switches, called transistors, on a tiny little chip of silicon. That's it. Everything we're about to see is just in service of that one single goal. So, our journey has to start somewhere, and it starts with making the perfect canvas for our microscopic masterpiece. And believe it or not, that canvas begins its life as plain old sand. So here's how it goes. First, sand, which is mostly silica, gets refined into something called electronic-grade silicon. Now, the reason we use silicon is that it's a semiconductor, which just means we can control exactly how it conducts electricity. But, and this is key, it has to be ridiculously pure. We're talking 99.9999999% pure. Any tiny little flaw can ruin the whole thing. This ultra-pure silicon is then melted down and grown into a perfect single crystal cylinder called an ingot. And finally, that ingot is sliced into these super thin, mirror-like discs that we call wafers. This is our canvas. Now, where does all this magic happen? It can't be just any old factory floor. This whole process takes place in one of the cleanest places on Earth, a clean room. And this isn't just a tidy office. We're talking about a place where the air itself is constantly filtered to remove particles 1,000 times smaller than a human hair. And that's exactly why you always see workers in those famous bunny suits. But here's the really wild part. Those suits aren't there to protect the workers. They're there to protect the chips from the workers. See, when you're working with circuits measured in nanometers, a single speck of dust or a tiny flake of skin isn't just a speck. It's like a giant boulder crashing down and destroying everything. It can completely kill a chip. All right, so we've got our perfect silicone canvas. We're in our perfectly clean environment. Now we get to the main event, actually building this microscopic city of transistors on the wafer. And believe it or not, we do it by printing with light. This whole process is called photolithography. I know, it's a mouthful, but the basic idea is actually pretty easy to grasp. Just think of it like developing a photograph in a darkroom. You're using light to project a really precise pattern, the circuit blueprint, onto a surface that's sensitive to light. This is, without a doubt, the most critical step in making a chip, and they do it over and over again. So how does it work? Well, it breaks down into 4 main steps. First, you coat the wafer with that light-sensitive chemical. Second, you expose it. You place a mask, which is basically a stencil of the circuit, over the wafer and blast it with powerful UV light. Third, you develop it. The parts hit by light get hard, creating the pattern you want. And finally, you etch it. You use chemicals to wash away all the unhardened stuff, leaving behind the perfect circuit shape. And then, you do it all again, and again, and again, sometimes hundreds of times, to build up all the complex layers of the modern chip. Now, the industry kind of splits this whole construction job into 2 big phases. First up is the front end of line, or FEOL. This is where you build the actual transistors, the capacitors, all the active components. These are the buildings in our microscopic city. After all the buildings are in place, then comes the back end of line, or BEOL. And this is all about laying down the metal wiring that connects all those buildings. This is the city's roads and power grid. And let's talk about that wiring for a second. Because, having billions of transistors is totally useless if they can't talk to each other. This stage is all about creating this incredibly dense, complex web of tiny copper pathways that turn all those individual components into one single functioning circuit. Okay, so once the entire wafer is fully printed with hundreds of identical circuits, we hit the final steps. First, every single circuit on that wafer gets tested by a machine. Bad ones get marked. Then, the wafer is diced up. Yep, like a pizza, into individual chips. A single one of those little squares is called a die. The good die move on to packaging, where they get put inside a protective casing with all the little metal pins you see on a chip. And voila, you have the final integrated circuit, or IC, ready to go into a device. So let's zoom out for a second. This whole thing doesn't just happen in one factory. It's a massive global ecosystem that is built on mind-blowing scale, precision, and a whole lot of specialization. Just to give you a sense of the scale we're talking about, look at this. The most advanced transistors today are just 3 nanometers wide. To put that in perspective, a single human hair is about 70,000 nanometers thick. You could fit more than 20,000 of these transistors across the width of one hair. The level of precision is it's truly staggering. Now, because building these factories, or fabs as they're called, costs billions and billions of dollars, the industry has become super specialized. A lot of the biggest players are what we call foundries. These are companies that do one thing and one thing only. They build chips that other companies design. Think of them as the master builders of the digital age. And you've almost definitely heard of the big ones. We're talking about giants like TSMC in Taiwan, Samsung in South Korea, and Intel right here in the US. These companies operate the most advanced and by far the most expensive factories on the planet. And on the other side of that coin, you've got fabless companies. These are the brilliant design houses. They're the architects who dream up the chips. They create the blueprints, but they don't actually own any factories themselves. They send their designs over to a foundry to get them built. And these are names you absolutely know. Think about NVIDIA, the king of graphics and AI chips, or AMD, who's a huge player in processors, or Qualcomm, whose chips are probably powering the phone in your pocket right now. All of them are fabless. They are the master architects who just focus on design. So after this whole incredible journey, if there's one simple thing to remember about how a computer chip is made, just think of this phrase. The entire process, from a grain of sand to your smartphone, is all about one thing: printing billions of tiny switches onto silicon. Makes you wonder, what are we going to be able to print next?